Hello everyone, today is day 27 of solving a LeetCode problem every day, and today we're going to be solving buy and sell crypto. I've solved this problem in the past before, but it's been a while, so let's try to do this together. So you're given an integer array of prices where price is I is the price of neat coin on the ith day. You may choose a single day to buy one neat coin and choose a different day in the future to sell it. Return the maximum profit you can achieve. You may choose to not make any transactions, in which case the profit would be zero. So in this case right here, we have 10, 1, 5, 6, 7, and 1. Our output is 6 because if we buy Neatcoin on this day right here, which is day 1, or I guess day 2 kind of. I mean, if we're talking about it from the zero index, this is day 1. Then we have 0, 1, 2, 3, day 4. So if we buy on day 1 and sell on day 4, we make a profit of $6, assuming this is in dollars or whatever it is. In this case, it's 0 because no profit's going to be made. So one thing I want to point out real quick is with this right here, it looks like the array is it's decreasing. At no point does the next number, basically it's in decreasing order. And since it's in decreasing order, we know there's going to be a profit of 0 because there's no chance to make a profit because it never goes above 10 or 8 or 7 or 5, 2 or whatever. So yeah, in this case, no profitable transactions can be made, thus the max profit is 0. The length of prices is always going to be between 1 and 100 inclusive, so we don't have to worry about an empty array. And the prices themselves are always going to be between 0 and 100 inclusive. Cool. So I actually drew out a little graph. I thought it would uh, help me solve this problem and kind of display it in a way that can make sense. But let's copy this test case right here. And let's try to think this through together. Sorry. So let's see. I'll use green. So I didn't label this. I should have labeled this, but this is days. So I guess the index of the array. And then over here we have price. Let me fix that. So on day 0, so this is 0, 1, 2, 3, 4, 5. That's a horrible 3. So on day 0, we have 10. On day 1, we have 1. On day 2, we have 5. On day 3, we have 6. Day 4, we have 7. And then finally, day 5, we have 1. And let's take a look at what's happening in this graph. So it goes here, here. You know, I probably should have done that with a different color, just so we can actually see it. But what I'm going to do is just draw over it. So we kind of have something. I mean, I know this is horribly drawn. Let me do that again. But I think this will get the point across. And then back down here. And then let me change this color to maybe red again. Then we can do this. We have 10, 1, 5, 6, 7, and 1. So I guess the goal of this problem is we have to find what day, or we got to find the max amount of profit that we can make. And it's pretty easy to see once you graph it out that the max profit is just going to be equal to, so the max amount of profit is just going to be equal to the minimum day, or sorry, the maximum day subtracted by the minimum day. So in this case, we have our max here, and we have our minimum here, and we can see that we're going to make the most profit because if we buy, this is the lowest day we can buy it on, and this is the maximum day we can buy it on. I mean, this is going to be the most expensive price we can sell at, so it would make sense to buy it here and sell it here. So to start out, I think we know we can calculate max profit by doing max minus min. So in this case, the output of this problem was 6. And as we can see here, we have 7, 1. 7 minus 1 is equal to 6. But now, let's actually try something else. So let's say that instead, this was at 0. So this went all the way down here, and it goes to 0. And then let's say we add an extra day, so day 6. And let's say day 6 goes to 1. So if I draw this out again, maybe it looks something like this now. So based on the algorithm that I said earlier of just max minus min, this might not work. And the problem is our new minimum isn't this anymore. Our new minimum is now 0 on day 5. And we can't buy on day 5 and sell on day 4. So what we got to do is we got to validate the fact that the minimum day comes before the maximum day, if that makes any sense. Like we can't buy on day 5 and sell on day 4. So that's the problem we're encountering with just doing it straight up like this. We need to somehow keep track of the fact that the maximum day is after the minimum day. And this is how I propose we can do this. So we can just have a pointer to whatever the current minimum is. So we can start that out as whatever's at index 0. And then we can iterate. And now we see that there's a new minimum. So minimum is day 1. So we point it there. And now we go to the next iteration. And in this iteration, what we can do is we can calculate the profit, but we can also have a max profit variable. And basically, every time we go to the right, we calculate the profit, we compare it with max profit. If profit is greater than max profit, then we just set max profit to be profit. And the reason why this would work now is because we are setting the minimum as we're iterating through the list. So the minimum is always going to be before the maximum. We're never going to have a case where we set a minimum and then and then we calculate a profit, but the profit is before the minimum, is because we're calculating the profit as we go with each iteration. So it should work this way. So let's try to kind of get this into code. So we said we need a minimum, and we can just initialize the minimum to be, let's call this min value, and we can just initialize this to be the first item in prices. What else do we need? We need a max profit, and I think we can just initialize this to be 0, because in this case, there's just no profit. We can output it. Then let's see. What else do we need? We need just a profit, but we can calculate that as we go. So now we want to loop through prices. So let's do that. Now let's see, what should we do? So maybe the first thing we should do is compare. So we can say min value is equal to min of min value, and we can say price is I, which is the current iteration that we're at. So we can fix this on each iteration. So if we have a new minimum value, we want to assign it. let's see. The next thing we're going to do is let's calculate the profit. And we can calculate the profit by saying price is I minus min value. So basically what this would do is, let's say min value here is at 1, but the current iteration we're here at 5. We'd subtract 5 by 1, get 4, and that's our profit. And then we want to set max profit to be the max value between profit and max profit. And then we know at the very end, we just want to return max profit. Now let's see. So we have min value, we start there. So let's kind of try this algorithm. So we have min value. So we have 10, 1, 5, 6, 7, and 1. Let's say min value is equal to 10, and then max profit is equal to 0. So our first iteration, we set min value to be, we keep it as 10 because we're just comparing it with ourselves. And then price is I, which price is 0, minus min value is just 10 minus 10, so that's 0. And max profit stays at 0. And now we can continue to the next iteration. Now we're at I equals 1, so over here, so min value is going to be the minimum value between the current min value and price is 1, which is 1, so this becomes 1. And now we say profit is equal to price is I minus min value. So let's see, price is I, so 1 minus min value, which is 1, we end up at 0. And then max profit is equal to max between the two, which stays at 0. I think another thing we might want to do is check if profit is less than 0. Because if that's the case, it shouldn't matter actually, because we're taking the max. So I was thinking originally, yeah, no, it should be fine. I don't think we need that. Let's keep going. So we were at 1, max profit is 0, but now we're at 5. So min value is the minimum between min value and price is I, which is 5. Not 5, sorry, it's still 1. Profit is now 5 minus 1, which gives us 4. So profit is equal to 4, but now we can replace max profit with 4 since that value is bigger. Okay, so now we're in the next iteration again, 6. Min value stays at 1, but now we do 6 minus 1, which becomes 5. Or sorry, the profit becomes 5, and then this gets replaced. The 4 gets replaced because profit is larger than max profit. Cool, so let's keep going. Now we're at 7, so profit becomes 7 minus 1, which is 6, and max profit becomes 6. And then we're at 1. We compare min value with min value. They're both 1, so it doesn't matter. And then we have profit equals price is I minus min value, so 1 minus 1 is equal to 0, and max profit stays as it is. So in this case, it seems like we got the right output. Now let's try another test case where we go like 10, 8, 7, 5. Let's just do that. So we got, let's say, min value, max profit, and that should be good. So min value starts out at 10, max profit starts out at 0, profit isn't currently calculated. So min value is equal to min between min value and price is I. They're comparing the same thing, so it's just 10. 10 minus 10 is 0. Max profit stays at 0. Now, again, we are on the second iteration, so now we're on this 8. So min value subtracts 10 from 8, or not 10 from 8, compares 10 and 8. It gets min value gets assigned 8 because 8 is a lesser value. Profit now subtracts 8 by 8, which is 0, and then max profit just stays at 0. So I mean, it's the same thing is going to happen again. 7 is less than 8, so min value gets assigned to be 7. Then you just subtract 7 by itself, and this stays at 0. So if I run this, I think the first 2 test cases should definitely work. Let's try submitting this. Cool, so this actually did work out. So let's see time complexity and space complexity. So as for time complexity, it's going to be linear, and that's just because we're iterating through the list once. As for space complexity, I mean, it's going to be constant. We're not creating any new arrays, hash maps, or anything. We're just storing the min values and profits and stuff. So it's going to be constant. And yeah, that's my solution for the day.